Let's talk about something I'm pretty sure every developer has experienced. You get a request for a simple change. You think it'll take 5 minutes, and suddenly your whole week is gone just chasing down bugs. Sound familiar? Well, that pain is often a symptom of breaking a core design principle. Today, we're diving into the first letter of solid S for the single responsibility principle. And let me tell you, really getting what this means, it's a total game changer for writing code you actually enjoy working on.
So here's our plan. First, we'll relive that all-too-common code maintenance nightmare. Then we'll get to the bottom of what one responsibility really means. After that, we'll look at how to spot when you're breaking the rule, how this one idea scales all the way up to system architecture, and we'll finish off by looking at some common mistakes people make.
All right, let's jump right in with a story that probably hits a little too close to home. The terror of the God class and the absolute mess it creates.
We've all been there. You get a ticket. It looks easy. Just change this one little thing. But you touch that one little thing and suddenly 3 other completely unrelated parts of the application just break. That's not you being a bad developer. That's a classic sign of code trying to wear too many hats.
And this image pretty much sums it up perfectly. We build these monster classes, these Swiss Army knives, that do absolutely everything. You know the ones I'm talking about. They handle validation, they talk to the database, they contain business logic, they send out emails, all from one giant tangled file.
And here's where it all goes wrong. When you cram all that stuff into one place, everything gets tangled together. It's called being tightly coupled. A tiny change to how you save to the database can all of a sudden break the password validation logic. It makes the whole system incredibly fragile and an absolute nightmare to test.
So, how do we get out of this mess? Well, the answer is the single responsibility principle. But here's the twist. The definition you always hear is so simple that it's actually kind of confusing.
You've probably heard this 1,000 times. A class should have only one responsibility. Seems pretty simple, right? It should just do one thing. But what exactly is one thing?
You can think of it like the Paw Patrol. It's a great team because everyone has a clear job. Chase is the cop, Marshall is the firefighter, Sky handles the air support. It works. Now, just imagine the absolute chaos if Chase tried to do all of those jobs at once. That's what we're doing to our code.
But this is where the wheels start to fall off. When we actually sit down to write code, what does one responsibility even mean? As you're about to see, just saying do one thing can lead you down a very weird path.
And this comment from a developer on Stack Overflow just hits the nail on the head. If you take one thing literally, you end up with something completely ridiculous. Do you really need a separate class for every single action? No way. That's just nonsense. It would make our code impossible to navigate.
Okay, so if do one thing isn't the whole story, then what is? Let's get to the real definition, the one that gives you a crystal clear way to know when your class is doing too much. This is the real aha moment.
And here it is. This is the key from the one and only Robert C. Martin, or Uncle Bob. A class should have one and only one reason to change. See the shift? We're not talking about what the class does anymore. We're talking about why it would need to be modified.
So what is a reason to change? Well, in the real world, changes come from people, a stakeholder. Someone from finance asks for a change in how reports are calculated. Someone from marketing wants to tweak the welcome email. Those are 2 different people, 2 different departments, 2 different reasons to change.
This table makes it all click into place. Think about it. The operations manager cares about the business rules in the order service. The database administrator, the DBA, they care about the database stuff in the order repository. These are different people with different concerns, so they represent different reasons to change, which means their logic should live in different places.
So now you can go on a hunt for these violations in your own code. Keep an eye out for some of these telltale signs. If a class name has the word "and" in it, that's a huge red flag. But for me, the biggest giveaway is a constructor with a massive list of injected dependencies. If your class needs help from 10 other services to do its job, it's a pretty safe bet it's doing too much.
All right, enough theory. Now that we know how to spot the problem, let's see what it actually looks like to fix it. We're going to watch a messy, do-it-all class transform into a clean, beautiful, maintainable design.
On the left, we've got our user creator God class. You can see it's trying to do everything. But look at the right. After we apply SRP, the user creator has a new, simpler job. It's just a coordinator. It manages the process, but it delegates the actual work.
We've essentially taken our one big class and broken it up into a team of specialists. We now have a UserValidator, whose only job in the world is to validate data. We have a UserRepository that is an expert on all things database. And the UserCreator is now the manager that makes sure they all work together.
And here is the big payoff. This is why we do all this work. Now, if the validation rules change, we only have to touch the UserValidator. The database code is safe. It's untouched. And testing? Oh, it becomes a dream. You can test each of these small focus classes all by themselves. Okay, so this is fantastic for our classes, but now I want you to zoom out with me and look at the bigger picture, because the really cool thing about SRP is that it's not just for classes. It's a core idea for designing entire applications.
That's right, this whole idea of separating concerns based on why they change, it applies at the highest levels of our software architecture.
If you look at an architectural pattern like clean architecture, you'll see SRP everywhere. It's SRP on a massive scale. You have the core domain layer, which is responsible only for pure business logic. Then you have the outer layers, like infrastructure, which are responsible for technical things like databases or web frameworks. Each layer has its own reason to change.
But look, like any powerful idea, you can definitely take SRP too far. This is a principle, not a law that must be followed blindly. So let's talk about a few common mistakes to help you be a pragmatic developer, not a dogmatic one.
The goal here is not to just split everything into the tiniest possible pieces. If you have a small class where everything is genuinely related and changes together, just leave it alone. Don't split things prematurely. Always remember the Yagni principle. You ain't gonna need it. Don't add complexity until you actually have a reason to.
So I'll leave you with this challenge. Go look at some of your own code. Pick a class, any class, and ask yourself this simple question. What is the one reason this class should change? If you can't come up with a single clear answer, well, it might be time for a little refactoring. Getting this right is the first huge step toward building software that's robust, maintainable, and honestly just a pleasure to work with.